Autodesk solutions for digital prototyping benefit from the accurate analysis results delivered by Autodesk Moldflow products. Leaders in the plastics industry rely on our products for accurate simulations that help them reach the optimum part and mold design and employ the most profitable manufacturing processes. Accurate plastics flow predictions depend on three major factors. The first is the accurate representation of your part geometry. The second is knowledge of the melt flow characteristics of the plastic, and the third is accurate calculations. All three of these factors are critical and interdependent. A number of thermal and physical characteristics determine the behavior of molten plastic, such as melt viscosity, its temperature, and shear rate. Simulation calculations rely on accurate interpretation of these thermal and physical characteristics. To take advantage of this information, however, we must look at the real-life behavior of molten plastic. When plastic fills a mold, the hot plastic that comes in direct contact with the cooler surfaces of the mold cools down, forming a skin of solidified plastic, commonly referred to as the frozen layer. Between these solidifying skins, the hot, still molten plastic flows to fill the more distant part of the mold. Temperature, pressure, and volume vary through the thickness of the part, so the flow of molten plastic through the part changes. It's vital, therefore, to model the thickness of the part properly to take into account these variations in temperature, pressure, and volume. In order to account for all the dynamic properties of molten plastic, Autodesk Moldflow analyses rely on a finite element mesh model for accurate results. A mesh is a grid of discrete, regular shapes or elements that the software uses to map the geometry of the part that it's modeling. More elements in the mesh produce a more accurate simulation. However, this will increase the analysis time. Fewer elements mean faster simulations, but potentially less accurate results. Autodesk Moldflow software engineers have developed three different approaches to represent the volume of the part, each with their own distinct strengths. For simple, thin parts, or for simulating specialized processes, a two-dimensional midplane mesh is used. Here we model the part with a mesh through the middle and assign a thickness attribute to each intersection or node of the part. The advantage of using the midplane mesh is the speed of analysis and the ability to simulate specialized processes such as injection compression molding. For parts that are mostly shell-like, such as interior car panels, Moldflow's patented dual domain technology typically provides the best analysis model with the lowest CPU times, resulting in the best combination of analysis accuracy and overall solution time. Here we mesh the surface of the model, matching the nodes on one surface with a corresponding node on the opposite surface to create a shell-like model. The software uses the distance between these nodes to determine the thickness through the model. This approach provides an accurate simulation of the flow of plastic through wide, thin sections of a mold. For parts that are thick and solid in nature, we model the volume of the part with a three-dimensional tetrahedral element. Using this method, we can simulate the flow of material around the part features like corners, bosses, and thick sections.
But if you use a fine mesh everywhere, you end up with lots of elements that take a long time to solve. So what Moldflow has done is we've developed meshing technology which guarantees a good resolution through the cross-section, but then across the surface of the part, we don't have such a high mesh resolution. And in complex geometries that are solved in injection molding, we can guarantee good mesh resolution through the thickness and an efficient mesh through the other directions of the part, so that we can get our simulation results in a timely manner that people need in today's engineering environment.
Autodesk Moldflow includes mesh creation functionality in both Insight and Advisor software so that you can complete the entire analysis from model import through meshing, analysis and export, all within the one software environment. So remember, there are three things required for an accurate injection molding simulation. First, you need an accurate analysis mesh model with the correct level of refinement. That is, sufficient numbers of elements to achieve an accurate part model. Second, you need accurate material data so that the values used in calculations reflect the actual behavior of the molten plastic during the injection molding process. Finally, you need fast, accurate solvers or calculations to process this information in a timely manner. Leading plastics manufacturers all over the world rely on Autodesk Moldflow products, part of the Autodesk solution for digital prototyping, because they deliver in each of the areas that are critical to achieve accurate analysis results.